All right, guys. Well, thanks everyone for joining us. And IDSA Seattle, for all the board members that are here or visible, wave your hands. I want to thank you. Thank you. Ginger is also in the background helping. She's called IDSA Seattle, but she's really much making sure everything's running nicely. So thank you, Ginger. I just want to introduce myself. My name is Herman Chan, IDSA board member and co-founder of Form Future, small design consultancy over here in Ballard, Seattle. So we've been working on an education series uh, at the board to really help our community advance their skill sets by partnering with such companies as Keyshot. And so we're very lucky to have Rhino partner with us today, actually in a two-part series. This is part one, which is focused on modeling. And then there'll be a follow-up part session that is in 2 weeks that will be focused on visualization. I want to introduce to you Scott and Kyle, who will be tag teaming this together from Robert McNeel Associates, the makers of Rhino. And I think without further ado, take the floor, please.
Thank you. So yeah, so my name is Scott Davidson, and I work in the Seattle office. And I'm gonna let me just share my screen here, if I can get this right. And so there we go. I'm just gonna quickly go through some of the what we're going to look at most closely today. We're going to look at some other things, but mainly we're going to look at sub-D modeling in Rhino 7. And so sub-Ds are a new geometry type that came along with Rhino 7. And it really defines, it really allows you to model things that previously you just wouldn't even imagine Rhino could do. And Kyle's going to get into the nitty gritty and actually work through part of a model and things for you so you can see how they work. But let me just kind of show off some of the style of models, some of the shapes that can be done. I believe all these renderings are done in Rhino 7 also, so you can just kind of see the range of things that now we find ourselves doing with sub-D. And so there's hard, kind of hard but organic models here. There's you're seeing some of this, but also you're starting to get into kind of the softer forms. Sub-Ds are very good at the blending between shapes. They're arbitrary in terms of the number of faces that they can come from, or the control net that they come from, and that gives them a lot of flexibility. Soft goods have become a lot more capable now with this. And I'm just going to jump through these a little bit. But you can see this is some other work that some of our people have done as we've worked through how this works. So you can see it can get very detailed. Sub-Ds can do hard edges. They also can do flowing soft edges. And all of these are, one of the nice parts about sub-Ds is that you can edit the edges, you can edit the faces, you can edit the control points of a sub-D, even when they're this complex, where when you go to a poly surface, for instance, in the traditional Rhino NURBS, once you get to a poly surface, you're kind of locked into that until you explode it or you extract it or something, part of it. There's another piece of this I'd like to talk about is, so we have on the left there, we've got, your complex shapes. Along with the standard sub-Ds, we also have what we call multi-pipe. And so if you look at the image on the right, they have a number of curves that they've run multi-pipe on, and that essentially creates pipes that are all, that are all smoothly welded together at the ends, kind of no matter how complex they are. And that's something else that a lot of people are using to their benefit in terms of rendering. And so that's what I have to show, just kind of so you can see the range of what you might even try in Rhino 7 now. And I'm going to move it over to Kyle now, and he can show you kind of how you can start laying out some models and actually use sub-Ds.
All righty. You see that and hear me and all that kind of stuff?
Yep.
Fantastic. So this is the model that we used for the cover image. And if we go to the wireframe, or sorry, the shaded mode on this, you can see basically what the structure is on this. And if I break out a piece of it and I just hit the tab key, you can see that in its very basic shape, it's basically just made up of squares. And so what I want to do is back up a little bit actually and talk about what I refer to as the paper doll method of modeling something. And the best way to break out subdies is to think about what you would do if you were trying to capture a shape just made strictly out of Post-it notes, right? So grab a stack of Post-it notes and start sticking them together and capture the basic shapes and everything that you want to capture, and you'd be on the right path to a correct topology layout for something in subdies. And before we jump into that, I want to talk about what I refer to as the rule of three. And the rule of three basically is how you make a corner in NURBS. And if we look at the basic layout of how you make a curve, we look at the corner here, these 3 points. And we'll, for argument's sake, we'll say this is a lead in, this is a lead out, but this is our corner. And you'll see that, you know, to make a corner in NURBS, you only need 3 points. We don't make a corner in NURBS that looks like this, right? Because the corner itself is going to be really, really jagged, and the continuity through this corner is going to be terrible. And if you've done any type of NURBS modeling, you may be consciously or unconsciously familiar with this already, but the way that we tighten the corner is we move the points closer together, and the way we soften the corner is we move the points farther apart. And so any transitions that we make follow this rule of three. Even if we were to do something like this and make a more complex shape, we can identify all of the 3-point pairs or the 3-point groups that make up the corner. So this is the corner for that one. This is the corner for that one. This point is shared. This is the corner for that, and so on, right? So we've got a shared point in the middle, but that's really of no consequence. But the rule still applies. If we want to tighten up here, we make these points closer together. If we want to make it looser, we move it farther apart. So with that in mind, when we start looking at the structure of how a subd is constructed, if I make a cube in here, I'll try to do one about the correct size, and we can identify the same structure, right? So for argument purposes, we'll say this is our lead in, this is our lead out, but this edge, right, corresponds with this point. This edge down here corresponds with this point. If we were to just look at this in a 2D world and evaluate it, we could say that this structure is identical to how a NURBS model is constructed. And if we wanted a tighter corner, we would simply tighten those points up, and consequently, if we wanted a softer corner, we would just move these apart and we would soften that up and we get a softer corner. So you already know a lot about subds to start with because of the skills that you've built in NURBS modeling. And the trick is to be able to understand how to make transitions in subds because they're different than in NURBS, right? In NURBS, we have a primary surface and a secondary surface, and then we have a transition between the two, or two primaries and a secondary, if you want to call the transition a secondary. In subds, the whole model is primary, and you just get the transitions for free by following this rule of three as you make a transition from one shape to another. So we'll talk about that a little bit, but I just wanted to kind of put that in your head before we get started here. And let's see, did I delete my image? I did. There we go. And so we'll start by just getting an object in here and talking about the topology. And in this case, if you imagine each one of these squares is a Post-it note, even though some of them are tortured, you get the basic topological layout. Now, when you start talking about transitions from one shape to another, the palm of the hand kind of has a topology that kind of looks like this, right? If we were to cut a section right through the middle here, you can see that this is a fat part and this is a low part and this is a fat part. So this topology may actually develop to the point where I may need to add an additional edge to get rule of three here and also here. That way I've got 1, 2, 3. That allows me to go up. I've got 1, 2, 3 that allows me to go down, and then I've got 1, 2, 3 that allows me to go up again, right? So that allows you to make your corners. But for the sake of argument in this and brevity, I'm going to just go with kind of the minimum layout here. So I'm going to take this image, and I'm just going to back it off a little bit so that we can model over it and see what we're doing. And then I'm just going to lock it. And then we're going to just go and start laying this out. And I'm going to just start with a single plane. And I'm going to just pick the easiest one, and I'm going to just kind of drop it in here. I'm going to switch to box mode. And I always say box mode is for modeling and smooth mode is for eval. I got a lot of pushback on that from the developers because they thought that you should model in smooth or limit surface mode. But ultimately, the way that I'm going to teach this is to model in box mode and evaluate in smooth mode. So we can just use the gumball to extrude some edges out here and add some additional topology, and hold down the control key as we extrude to add some additional edges. And then we'll just simply come in here and do some really quick edits to follow our layout. And a lot of times if I'm struggling with how to lay something out, I will actually take the image and I'll just draw right over top of it and actually just do, you know, what I refer to as the post-it note layout to figure out how this thing is supposed to come together. And it makes it a lot easier to try and figure out where everything is supposed to live. We can extrude multiple edges so that once we start developing, this whole process starts to move a little quicker. And using that extrude dot on the gumball allows you to basically do most of the functions that you need to do right in the modeling window. You can see that I haven't had any menu picks yet because it's all kind of happening right here, which makes it really fast, really accessible. I'm sub-object selecting by holding down Control Shift, and that allows me to be able to pick, not only if I'm in shaded mode, it allows me to be able to pick a face, it allows me to pick an edge, or it allows me to pick a point. So there are filters in Rhino, but you don't need to use them with the sub-object selection because it's really easy to kind of identify what you want to work on. So just by doing that, we've laid out the hand here, and we've got the basics of the palm, and we're going to add the fingers. Now, if I were to grab this entire edge and extrude it, we'd get a flipper out here, and that's not what we want. So I'm actually going to skip, and I'm going to extrude these two by themselves. And then I'm going to extrude the other two by themselves. And what that does is that creates two separate paths. Oops. Two separate paths for this topology to flow, and it creates a separation between the two. I don't know if you can hear in the background, I've actually bored my dog asleep, and she's now dreaming underneath my desk. She's seen this demo a few times. All right, so let's just finish this out real quick. And once we have the topology laid out correctly, and we have everything flowing the way that we want it to flow, and everything laid out the way we want it to lay out, adding the form is actually really, really simple because you get the transitions for free. All we have to do is add some thickness and go from there. Now, because these are all separate, I can extrude them all together because they're already disjoint and pulled apart. I don't need to worry about them sticking together. And that is essentially the basics of what we need to do. And I'm going to just unlock and hide this image for now. And you can see that if we hit the tab key and we switch to smooth mode, you can already see what's starting to happen, right? We've created this organic shape. And then it's simply a matter of just coming to the subbeam menu. And I'm going to move down a little bit. Let's see, move this tab off the top. There we go. It's covering up my menus. And we're just going to add some an extrusion or an offset to this. And we're going to just offset it. I'll just say 1 unit for now. And then we are going to make this solid and we are going to delete the input. And we get a solid object. And if we hit the tab key, it switches to smooth mode. And you can see that it has creased edges. In order to get it to be round, I'm just going to simply uncrease the edges. And you can see that within, a couple of minutes of starting this, we have a fully realized kind of 3D object that would be very, very difficult to model in NURBS. And the fun part about this is if we look at this, it is, gorgeously organized and has amazing reflection characteristics. And if I were to emap this, you can see that the highlights on it track really, really beautifully. And so that's kind of the beauty and the power of SubD, is once you get your topology laid out, the model kind of falls together, right? You get your transitions for free. How many times have you been deep into a model and just had to sweat the fillets and the transitions and the continuities and, oh, this is a really smooth surface, but for whatever reason, my fillet or my blend didn't lay out, and there's a kink in the zebra or whatever. SubD doesn't have that problem because it just happens organically. So that's kind of like a quick little primer into what I refer to as paper doll SubD modeling, which is to just lay the part out flat and then go from there. The next thing I want to show you is what you do when you kind of get past the paper doll stage. And if we look at the image of this Formula One car, and we start breaking this down into rule of 3, right? We know that there's, from the section, we know there's a little transition here. So I need 1, 2, 3 edges through here. There's another kind of a rounded transition here. So I need 1, 2, 3 edges there, because I have to have that center edge in order to be able to pull in or out in order to capture that form. There's another edge, another rounded edge here. And then, we've got some stuff to lay out, throughout the rest of the car. So if we lock this thing, I can actually go and create, I can create SubD friendly curves, and I can actually start laying this entire thing out with curves instead of actually having to go and place each specific face individually. And I can kind of come in here and just capture my flow. I don't need to get too crazy with it, but that should give us about enough that we need to do in order to start laying out some patches. And so we can come up here and do a SubD loft. And I can loft these curves together, and I can start messing with how much division I want, right? And in this case, I probably only need 1 additional edge, because that allows me that center point in order to be able to pull that in or out. I don't need 4, I don't need 5, unless I have to have a compound transition. Then you say 1, 2, 3, that's your first corner, 1, 2, 3, that's your second corner, 1, 2, 3, that's your third corner. The tendency with SubD is to put too much stuff in it, right? There was an old joke. I went to Center for Creative Studies as a car designer years ago, and we had a guy from Lotus actually give us a talk, and he said that Colin Chapman's philosophy on building race cars used to be, he would build a chassis and then he'd start taking parts apart until it collapsed under its own weight, and then he'd put one more part back in. And that's where this whole kind of simplify and add lightness philosophy came from. SubD follows that same mentality, right? You want to simplify and add lightness. You want to take stuff away until the model falls apart and then put one thing back in. You don't want to keep adding, because of the same reason that we only make corners with 3 points and not this, right? It's the same reason that we make SubDs with simplified faces as opposed to trying to force more that we don't need. So let's go ahead and loft these together. And I'm going to add one more shape there, and then I'm going to adjust the shape segments, and I'm going to probably add, I don't know, a few more. Maybe that's too many, maybe that's not enough. We can always add or subtract later, but 8 feels like kind of a good place to start. It gives me 3 segments back here, which I can then pull. I'm going to get rid of my curves now because I drew those curves, but I think I'm going to switch ideas, and I'm just going to pull these from here because I'm kind of already set up to do so. So I'm going to just pull this up, and then I'm going to do the same thing again. I'm going to pull this up again, and that gives me kind of my basic layout. And then maybe I'll go one more just to capture that, and then we can go to wireframe and kind of see where we are. Again, I'm going to switch to box mode because box mode is for modeling, smooth mode is for evaluating, and I'm going to just start putting these points where they belong. So that one goes up there, this one goes back here, these two are going to come down. All of this, I'm going to scale in one direction from here and just pull all of that down nice and proportionately. And then I'm going to scale these all to 0 and flatten them out. Then kind of tuck it in here about where I think it should go. And then I can rotate and scale if I need to. And that gives me kind of the basic layout. Maybe what I'll do is I'll clean up this flow a little bit. This is a little jaggedy through here, so maybe I'll straighten these guys out a little bit. But most of the work in SubD comes from getting your initial patch layout. Now we've got our Formula One paper doll, right? And I can double click this edge, and look what happens when I pull this. I start getting shape, right? Because 1, 2, 3, right? Those are my rule of 3. So that's my corner right there. I'm going to grab this edge and possibly this one. I'm going to push these in a little bit. And you can see that the sculpture starts to reveal itself. You know, you can really start to see what this thing is going to do, and you can start playing with it and say, okay, well, there's my secondary light line. Again, 1, 2, 3. Those are the 3 points that make up that transition. It doesn't have to be any more complicated than that. And then we can start doing things like refining, and we can say, okay, well, does this pull down or does it pull up, or is it, is it decelerate or accelerate, depending on what the curve is going to do or what the form that we're trying to capture is going to do. But you can see that you can start doing things like establishing what your highlight lines are going to go. And one of the cool things about Rhino is the new rendering system and the display system it's set up. I can get let's put a paint on this, and let's do a nice red. And I can even start evaluating my highlights in real time. And so I can say, well, I think that's really cool, and I love how this highlight is tracking down this surface. Let me turn on my edges. I can actually even work in this mode. And I can say, well, this is cool, but I kind of want this thing to fade out. So let's go to the top view, and let's apply a bend deformer. And we're going to use a bend deformer to actually procedurally move that edge and create that really nice, beautiful taper in there. So you can apply UDTs onto sub-Ds and all sorts of stuff like that. So let's say we've gone down the road and we've conquered this, and we've got it laid out exactly the way we want it to. I can simply mirror this. There is a reflect feature, but for this particular case, I'm going to just mirror it. And then I'm going to pull this apart, and since I did it with history on, I can decide how thick I want this thing to be. And then I can just start attaching it together, and I can click all of these edges, and I can either bridge them or I can stitch them, and the model starts to just kind of sew itself together. And let's click, oops. Let's get some edges here. Get this one and this one. Double click to fill it in. This one and this one. Double click to fill it in. And then let's stitch that together. It starts to pull itself together like that. All right. And so the cockpit, we can start to just establish that. We can grab this edge and just start extruding down to roll that edge. And then it's just a matter of kind of picking points and moving things around in order to start adding the additional details that we want. And then if we wanted to switch back to box mode, I would look, this is why I say model in box mode. See how I kind of tortured that where I pulled these polygons through? That's the best way to evaluate whether or not you're killing your model, is to go back into box mode and straighten it out. In this case, this edge and this edge need to come together. So I'm just going to scale those in until they stop breaking through. And then this point in here, I pulled this point too far. So let's straighten that one out. And it's a very clear, it kind of shows you exactly what's going on and exactly what you're breaking. And to get a rounded edge on this, I'm going to just grab all these and stitch them together. And then we'll take this edge and we'll pull it forward. And it gives us a nice round nose on that. Then we'll go back to box mode, and we want to pull out the pull out the side object, the intakes. We'll just grab these faces and we'll just simply extrude them straight out. And then we can grab these faces and extrude them in, shift scale, and take a look and see what we've got. You can see that we've created that shape where you can see that we're starting to get this together, where we've got the basic topology, where we've got everything that we need to start working with. Once I get it the way I like it, I'd probably run the reflect command. And then I've got an editable object that updates in real time as I model. Okay, so I'm not going to go too much farther with that just for the sake of time, but I just wanted to show how easy it is to go from a flat paper doll into something that is, really quite complex. And then, it's just a matter of going back and referring to your art and saying, okay, where am I missing my art? I'm just going to go back and I'm just going to place these points exactly where they're supposed to be. And without a whole lot of effort, you can start getting shapes that do what you need to do really, really quickly. All right, any questions on that so far? I haven't been monitoring the chat. The next thing,
I've been watching the chat.
Okay, cool.
They're making it really easy on us.
Okay, good. Good. So the next thing I want to show is quad remesh.
I think we're just speechless. That's it.
Nice, good. That's a problem I've never been accused of having. So, so let's get rid of this for the time being, and then let's look at the next thing, which is quad remesh. And quad remesh is something that I've done a lot of reverse engineering over the years, and this is one thing that kind of just absolutely rocked my world when I first started using it. I've used Geomagic, I've used Paraform, I've used a whole bunch of stuff in order to get meshes into NURB surfaces. And in the past, what you used to have to do is project curves onto a mesh, extract those curves, rebuild the curve because it's all a bunch of connected degree one straight line segments and makes terrible surfaces. So you'd have to rebuild those curves, and then you'd have to rebuild the surface, and then you'd have to compare it to the mesh, and then you'd have to manually adjust it, and then it's like back and forth and back and forth. And it was something that just was absolutely positively crazy. And so I'm going to talk about this and I'll break down each step, but I just want to show you how fast you can reverse engineer something in Rhino right now. Oops, not that one. So this is step one. This is step two. This is step three. That, my friends, is a closed NURBS polysurface. And if I hide some of the isoparams, that is what it packs out to. So this is a NURB surface, this is a NURB surface, this is a NURB surface. And if we look at the edges, there's no naked edges, no non-manifold edges. This is a closed manifold watertight part that you could work with. And the topology on it is such that these surfaces are packed in a way that you could actually work with them. I don't know if you've seen what Geomagic does when it auto wraps something, or what you know, say for instance Paraform or something does. You either have to lay the stuff out manually. If you use the auto wrap function, it almost looks like somebody took a hard-boiled egg and cracked the shell but didn't peel it off. You know, it's like all crackly, and it has these weird kind of flag shapes on it and stuff like that. This is solid. You could take this and send it to Pro E. You could take it to SolidWorks. You can Boolean it, you can cut it, you can trim it, you can shave the top off and fillet it. If we take and just knock this off, it wire cuts beautifully. And if we wanted to run a fillet around the top of this, we could do so and get the best of hard mechanical shapes on top of the organic stuff that the sub-Ds allowed us to create. So let's back up just a little bit and talk about what just happened here. Because I had to do it a few times. The first time I saw it myself, I was like, wait a minute, show me that again. So we have an unorganized mesh, right? So we're going to say this came out of a scanner. And this is actually a particularly nice mesh coming from a particularly nice scanner. But most of the stuff that you're going to get scanned is going to be garbage. And so there are some mesh repair tools up in here. The ones that I would look at most specifically are patch single face and then fill hole, fill all holes. These three tools right here allow you to be able to repair something that has damage to it or has holes in it. And once you get the mesh so that it passes the naked edges, no non-manifold, you can then run quad remesh. And what quad remesh does is it takes input. It'll take a NURBS object, it'll take a mesh. So you can do this with a NURBS object as well. So if you have a polysurface that's made up of a bunch of surfaces and you want to kind of unify that thing and turn it into a sub-D, this is the path to doing it. We have a target quad count, we have adaptive size, and then we have the ability to use either existing surface edges where it'll read there and find any type of corners in the mesh and use those actually to help generate guide curves. We also have the ability to force symmetry. We also have the ability to use guide curves in here. So if we wanted a particular flow, say for instance, we wanted to really specifically capture a flow line right through here, and we wanted another one that kind of came through here like this, and then we wanted another one that kind of came through here like this. We can grab these three pieces, we can project those onto the curve or onto the mesh, and then we can run quad remesh. We can select the guide curves, and then we can let it run. We can preview it or whatever we want to do, but I'm just going to let it run. I'm actually going to drop this down to like 500. So to go back and reinforce what I said earlier about not adding more stuff than you need. And what it'll do is it'll evaluate those guide curves, and you can see the result. The mesh follows that suggestion of the curve in order to be able to help you get the type of topology that you're looking to get. So this is now just a mesh. This is just a closed mesh, just like anything else. You could print this, you could OBJ it, you could send it to ZBrush. These meshes convert wonderfully in ZBrush because they're all quads. And so if you wanted to take this into ZBrush and subdivide it and texture it and do things like that, it goes in really nicely. The step from here into sub-D is simply just running the to sub-D command, and it basically takes this quad mesh. It uses the control points. There's no creases in it right now. There's no corners in it right now, and things like that. And I am going to just go ahead and delete this input, and it just takes, and you can see that very slight change right between that and this. It just went from a mesh to a sub-D, and so now this is a fully editable sub-D. and we can do things like edit it using like a bend deformer, and it edits beautifully just like any sub-D that you would want to use for anything else. We can add to it, we can subtract from it, we can extrude pieces out of it. This is the new Robert McNeel sneaker coming right at you for release 2021. And anything that you could do normally with the sub-D, you can do with this. We can also take this and we can apply creases to it. So if we needed a hard edge, we could crease that and do what we needed to do there with a hard edge. Okay, so this is a fully functional, fully realized sub-D. And once you have a sub-D, getting that sub-D into NURBS is just as simple as running to NURBS. You've got two options: delete the input or packing. And the extraordinary verts, we can set them to G1, G0, G1X, or G2, depending on your needs. And in this particular case, I'm just going to use G1X, and I'm going to use the faces packed, which means it's going to try and take as many of the patches as it can and expand them into single surfaces. If you don't pack it, it's 1-to-1. You'll get a surface for every sub-D face. Sometimes that's useful, sometimes it's not. I typically run packed and see how it goes. And then you can see that we can just compare the two, and they are dead nuts on top of each other and give us really pretty beautiful results. I already EMAP these. You can see that they look pretty darn good. So this process right here, I don't know how many of you have done reverse engineering in the past, but this process used to be the most tortured, the most painful, the most expensive, difficult. I would reverse engineer 4 parts that were scanned, right? So like you'd have a couple of pieces, they'd all be about the same size, they'd all come off the same scanner, they'd all come off have the same polygon count. You'd have to use a completely different process in order to reverse engineer each single one. It was never the same. It was, I used to say it was the department of voodoo and chicken bones, because it was like you would just sit down and try and do this, and you'd be like, I just did this. All I have to do is follow the same process. You follow the same process, and it'd be like, no, we're not doing it like that. So in order to have a tool like this, where it's basically just like step 1, step 2, step 3, step 4, and you can just do it over and over and over and over again, the repeatability, the consistency, the quality, and the speed, I mean, this is just absolutely straight murdering systems that, you know, are $30,000 and $40,000 that it used to cost. I think a seat of Geomagic back in the day used to be like 38 grand, and it had to have a monster machine to run on because it was just incredibly computationally expensive. But, you know, and I mean, in typical McNeel fashion, we're just like, oh, and by the way, we're just going through this tool in, and you can have it and play with it. And if you like it, it's cool. And if you don't like it, then don't use it. It's fine. We don't care. And, you know, and meanwhile, it's like cracked open this whole world of reverse engineering that was previously unavailable to folks like us who are running, you know, design consultancies out of our basement and trying to compete with design firms. And yet here it is, fully formed in the point where you can go take a next engine scanner or a photogrammetry scanner or, you know, whatever, and go out and pull stuff from the world and bring it into Rhino and actually have it be usable and be stuff that you can build off of. And so the speed, the time, the flexibility, the opening of the capability for folks like us who didn't have access to this in the past is just something that I still, you know, I watched this develop from the very beginning, and every time I use it, I still just kind of go, oh my God, I can't believe we have this. So that's kind of what I wanted to show you for today. And I think, yeah, we got in about 45 minutes. So I wanted to just kind of leave that with you. And then this is more of the stuff that kind of came out of the development that was all sub-Ds. And so one of the things I wanted to show is the variation in what sub-D can do. You know, very typical kind of sub-D things like this turtle, versus something like this pedal car that's much more linear and graphic. And, you know, even something like this that was kind of hard edged versus the shoes that are, you know, very soft. And so the ability to be able to explore forms and kind of capture different shapes with sub D, I find it a lot easier to do in Rhino than it was at sub D. I don't know if they mentioned that I was the demo guy and the tech and the trainer for T-splines back in the day. But T-splines used to be, you know, you'd get down the road and your model would shatter and you'd be like, okay, I guess I just have to stop modeling here because we're done. The Rhino stuff is like, is really, really durable. I haven't been able to break it. I haven't gotten to the point where you experience that sub D model shatter like T-splines used to do. And I also haven't run into situations where you can make topology where the model breaks. It's based on Catmull Clark. It's the same stuff that Pixar uses, the same stuff that Disney uses, and it's just bomb-proof. It's like taking every single thing I could possibly throw at it, from stuff like this little Testarossa in the motorcycle to ridiculous things like this fish, to this chaparral, which was something that I did that I wanted to experiment to see what would happen if you start trying to throw sharp stuff in there. And so being able to get definition and sharpness out of a model is something that is difficult to do in sub Ds. I don't know if you remember when Photoshop first came out and people started drawing on tablets, everything looked fuzzy because they were all using brushes that were about this big and super fuzzy, and there was no definition in anything. And sub D's kind of the same way. To be able to kind of get that crispness and stuff, to be able to manage that, and it's absolutely positively 100% doable. So I've been super impressed with it, and I hope you guys get into it and dig it as much as I do, and give us your feedback and let us know what we need to change and make better and all sorts of stuff like that. So
yeah, so we can take some questions for 10 minutes or so.
Yeah.
Kyle, really quick, you mentioned, or you showed in a previous image, someone using like a sub D pipe.
Yeah.
Kind of feature. Is that something you could demonstrate super quick?
Yeah, absolutely. It's I call that the instant bike frame tool, and that one is actually really pretty cool because you could do something like this, and we can design. Let's design a bike frame really quick, and that's a little crazy for bike frame. So this would typically be a very difficult form to try and model if you were doing it with tubing, right? You'd have all these transitions you got to model, especially this 4-axis joint, and actually bicycles, this is called the 5-axis joint, and because it's got a little piece that sticks out like that, but for today we'll just make it simple on ourselves. And if we do multi-pipe, we just go boop, and we say, what's the pipe radius? I don't know, 1 unit should be probably fine. And then I'm not going to cap the ends. I'll just leave it off and say, go. Actually, that's huge, so let's do it smaller. And with a couple of clicks, we have, congratulations, we're now in the carbon fiber bike business. And so you can look at, the transitions you get out of this are beautiful, but you also get them for free. And it looks like this joint right here, if I had split this guy, let's fix that. It looks like I'm not on here, so let's fix that. Let's grab all these. And let's stick them to this guy. There we go. As long as they're touching, the solver will take that and call it a day. So you can see that it actually built that right in there for us like that. If we go to box mode, you can see how simple this topology is. And you can see that, you know, here's our rule of three, right? 1, 2, 3. If we need the tube to go up, we pull here. If we need it to go down, we pull here. You know, now you've got your step through. Now you've got your Amsterdam frame, right? We grab this and we just go near, and now it's an Amsterdam frame. And so you can start playing with this stuff and decide how it is that you want these transitions to happen. If we want this transition to happen sharper, right now this is our 3, right? 1, 2, 3. So these are the points that make up our transition. If we need that to be tighter, I can come up here and add an edge and just pull it up like this. Now these are my 3. And if I switch that, you can see that that tightens up, right? And we can pull this apart and make it softer, or we can tighten it up and make it really tight if we want to. And if we pull this guy down, we can really sharpen that corner up. So it just, as long as you keep that rule of 3, and it's not 5, it's not 17, it's not 25, it's 3. You know, 1, 2, 3 corner, 1, 2, 3 corner. Think about breaking your stuff up in this and this and this and this, and those are just 3 edges. Here we go. But anyways, that's multi-pipe, and it's really, really cool. It's a really cool tool and allows you to be able to do a lot of stuff, especially making bike frames. So take that, track.
So we've talked a bunch about using this rule of 3 to make your nice corners and to control the geometry. And you mentioned that sort of the less is more philosophy.
Mm-hmm.
Can you talk a little bit about what you would do? Like some of us, I think when we're first starting using this tool, we might use too many points and things like that.
Overdo it. Yeah.
Yeah, and like what that workflow looks like. Like, would you just scrap it and start over, or would you like go through one by one, and how would you correct that?
If you let's say this is massively overdefined, right? And technically speaking, if we went from here to here, we would really only need maybe 3 or 4 edges, right? So let's just double click and delete. Double click and delete. And I'm taking out every other one just to kind of keep an eye on what my shape does. And as you get closer to too much, right? Now we've lost our form there, right? So we've started to lose our shape. I just undo and I put one back in. And then I would switch to box mode and I would start pulling and pushing in order to get my shape back to where I wanted. But it's totally acceptable to come in and start just removing stuff that you don't need. And in this case, you know, some of the edges, the way the edges are looped together are not ideal. You can see that that's all one edge. So maybe what we would need to do is go in and selectively pull out a couple of things. We could even pull out a row of faces and then stitch stuff back together. So say, for instance, we didn't like any of this. We just hogged it all out. We just said, goodbye. And then it would just simply be a matter of trying to start knitting this stuff back together. And we could do that with the stitch. We can just start stitching stuff, you know, as needed, and start pulling those things together and putting this thing back together however it is that we chose to do so. And so when you run into topology issues, I find the easiest thing to do is just to start making holes and then start either bridging back over or things like that. So I can take, like, say, from this edge to this edge, and then this edge to this edge. I think that should be close to about the same. And then we bridge. Let's see if I picked the right ones or not. Let's make a guaranteed success example here. Bridge. So we're just going to pick these 4 edges and these 4 edges. And we'll just bridge those together. And if I want more than one segment, I can click up here and I can roll my mouse button and I can decide how many edges I want. In this case, I only want 1. And then I would just simply grab this edge and this point and stitch those together. And start pulling it together like that. Actually, probably wouldn't do it like that. I'd probably add an edge from here to here. Let's do that. And then add an edge from there to there. And then I'd probably get rid of these two faces. And then I'd probably bridge those two with one segment. Start putting it back together like that. You can modify the topologies as much as you want. You know, think about it like this. Post-it notes are disposable. You can take these things and tear them apart, throw them away, whatever you want to do. It's easy to get more and just start sticking them in there to get it to go, to get it to do what you want it to do.
I think we have 1 minute left for one more question if anybody has it. All right, well, I guess that's good. We did post a link to the tutorials, and Kyle has a lot more tutorials on our webpage, and so you can go there, and then this presentation will be this presentation will have a video, or this video will be recorded, so you'll be able to watch that too. And I think we'll pass this back to IDSA.
Kyle, Scott, this was incredible. I think reading the chat, one person said this is a personal game changer, and I think a lot of us would agree with that. So amazing. Yep, we will have this recorded, and we'll be posting up on IDSA Seattle, Seattle's LinkedIn, Facebook, and Instagram. We also have in 2 weeks, same time, 2 weeks Thursday, Rhino will be presenting also the visualization part of Rhino 7, which is also, when we talked about it, like game changer. So yep, Ginger just posted the Eventbrite for everyone to click and sign up for. Thank you all for joining us today. Again, thank you so much, Rhino and Bob, for joining too. And let's see, Rhino 7, yep. Awesome. Great. We'll see you guys really soon.
Great.
Thanks, everybody. Nice
Thank you
meeting
very much.
Yep. Bye.